Hi, this video is about graphing rational expressions or rational functions. Graphing rational functions. When you graph rational functions are just fractions. Rational just means fractions with the function. Okay, so when you do this, first of all, I think the best way is first identify your horizontal asymptotes. Second, you would identify your vertical asymptotes. Third, you would identify if there's any discontinuities or holes in the graph besides those asymptotes, because those are also points of discontinuity or lines of discontinuity. And then you'd plug in points and sketch the graph. This is the order that we do it in. So I'm going to first talk about what horizontal asymptotes are. There are two ways horizontal asymptotes can happen. If the highest degree, the degree is like squared in this case, right? The highest degree are the same on both the top of the fraction and the bottom of the fraction. You just take the coefficient in front. So this one would be 1/4. So the line y equals 1/4 would be an asymptote. And an asymptote is a line, or you could think of it as a brick wall where the graph gets really, really close to it but can't touch the brick wall. If you had plain old x over x, you'd just have the coefficients being 1. The degree of the polynomial would also be 1. But if this is the highest degree, you'd just say y equals 1, and that would be where your horizontal asymptote was. And remember, horizontal asymptotes just makes a horizontal line. The other way horizontal asymptotes can happen is if on the top of the fraction or in the numerator, the power, the highest degree is 1 degree lower than the bottom. So if this is smaller, 1 is smaller than 2. What happens is as you get really big numbers down here in the bottom, because you're squaring them or you're doing them by a higher power, that you get like a small number over a big number. And this asymptote goes off to be a really small number at the ends, because you always think about asymptotes at the end of the graph, the either negative infinity or positive infinity ends. And as this happens, your fraction would get really, really small, and it would be really close to 0. So these are the only two options for horizontal asymptotes. Okay, let's talk about vertical asymptotes. Vertical asymptotes are vertical lines. So they make like a line. All right, vertical asymptotes happen when you set factors equal to 0, or you set and it has to be in the denominator, because you know that this would be undefined. And that's what you're just saying. This is where the graph is undefined, and it doesn't. The graph can't touch that, or the graph can't happen there. And on this one, the graph can't happen at +3, because I took this factor right here. I took this factor, and I said, oh, well, I know I set that factor equal to 0, and I solve. So I get +3. So I'm going to have a vertical asymptote at the line x equals 3. There's another type of asymptote, and this is called a slant asymptote or an oblique asymptote. So it makes a diagonal line. These are linear. These make linear asymptotes. They make lines, but they're on a diagonal. When you have a slant asymptote, because if you thought about this, this would reduce, right? 3 x's on top, 2 on the bottom. They would cancel, right? So, bye-bye. So I get y. I get the line y equals x. If there are numbers in front, so this is when the numerator is 1 degree higher than the denominator. Numerator, denominator, right? The numerator is 1 degree higher. This would become a slant asymptote. Now, we haven't done long division in here yet. So long division is how you would get the y-intercept of the line. So for right now, though, it's okay for you just to know if there's numbers out in front, like if there was 1/5, that would be the slope of the line. So you can get the slope by just looking at whatever the coefficients are of this slant asymptote. Okay, let's talk about this problem. This rational function, I would first of all look at to see what the horizontal asymptotes are. And because this degree, the top is 4x and the bottom is x squared, the power is 1, this is 1, right? 1 degree lower. Then when the bottom is higher, it's always going to have a horizontal asymptote at y equals 0. Okay, next, we got to decide if there's a vertical asymptote. So I'm going to factor these. So you factor them, you go, oh, all right, there we go. I factored the top, I factored the bottom. All right, they're both negative. Okay, so I factored the bottom. And basically, now by looking at this is the horizontal asymptote, y equals 0. I next do vertical asymptotes, which will be, they would be x equals positive 2 and x equals 3. Except for, now I can talk about holes. Instead of x equals 2 being a vertical asymptote, there is going to be a hole, because these are common factors. So you cancel these, and that is where your hole would be, at x equals 2. That's where the hole is, and now this is not a vertical asymptote. What I need to emphasize here is that either you have a horizontal asymptote or you have a slant asymptote or oblique asymptote. You do not have horizontal asymptote and slant asymptote at the same time. You either have horizontal or you have oblique. Okay, I'm going to talk about sketching the graph. I sketched the graph here for you. So the first thing I do is I put the asymptotes on. So I did the horizontal asymptote at y equals 0. I did the vertical asymptote at x equals 3. Then I plotted points. I just choose some points to plot. And I chose 4. I choose these. These are independent variables, the x's. So I put a 4 in for x. Okay, so if you put a 4 in for x, you get 4, because that's already the problem, that 4. And then you do 4 minus 3, and that gives me 1. So 4 divided by 1 is this 4. So this is an ordered pair, 4, 4. I put another point in. I'm going to put 5 in. Okay. So I put 5 in. I put 5 in for x. So instead of x, I'm putting 5 in. 5 minus 3 is 2. 4 divided by 2 is 2. So this is my ordered pair. So now I know this is where the graph is going to happen. So I sketched those points. The other thing I did was found my hole. So I plugged the hole in to the new equation. This is the new equation after you cancel off the common factors. I plug in the 2 for x. 2 minus 3 is negative 1. So now if you go back to my picture, you can see I plotted the point 5, 5, 2, and 4, 4. I plotted those in green on this graph, and then I drew my curve. And I know that the 1 over x graph, the parent graph, looks like this. It has these curves in the sort of opposite quadrants. And then I put my hole. My hole's in purple there. This is rational function, graphing rational functions.